In this video, we will use technique of integration to convert a gradient function into the equation of a curve. Let's first get started with the idea of the equation of a curve, such as y is equals to x square plus 3x plus 1. And the usual question is about asking the equation of tangent to a curve at a particular point, for example 1, 5. So how do we get started with this one? The rule is pretty simple. We differentiate the equation. We find the gradient function dy by dx, that is 2x plus 3. We plug in the value of x is equals to 1. So dy by dx comes out to be 2 into 1 plus 3, which comes out to be 5. In other words, gradient of tangent is the same thing as the value of the gradient function at a particular point, which in this case is 5. And then we can find the equation y minus y1 is equals to mx minus x1. 1, 5 is the coordinate, gradient is 5. Therefore, the equation is y minus 5 is equals to 5x minus 1. This is the equation of the tangent. This is what we have learned in the topic of differentiation, that we have equation of a curve and we use the gradient function to find equation of tangent at a particular point. Now, let's do the reverse. What if the question is dy by dx is given as 2x plus 3? Second piece of information is that the curve passes through the point 1, 5. So we are given the gradient function. We are given the info that the curve passes through the point 1, 5. What is the question being asked? The question being asked is find equation of the curve. So now what do? We take the gradient function dy by dx is equals to 2x plus 3. And we know that if we differentiate y, we get dy by dx, which means that if we integrate dy by dx, we will get the equation of the curve. So that is the process that is being applied. Instead of dy by dx, we will write y and we will integrate 2x plus 3 dx. Therefore, integrate 2x, that is 2 as it is, the power of x is increased by 1, divide by the new power. The 3 becomes 3x plus a constant of integration c. Therefore, it simplifies to 2x square over 2 plus 3x plus c, which can be further simplified and written as x square plus 3x plus c. Now we know that the point 1, 5 is on the curve. That means this is the x value, this is the corresponding y value. We will use this particular point to evaluate c. So y is 5, x is 1, 3 times 1 square plus c, c is unknown. 5 is equals to 1 plus 3 plus c. 5 is equals to 4 plus c, make c the subject, that comes out to be 1. So this is the first time that we have evaluated the constant of integration. This is the symbol for integration using these 2 points 1, 5. Therefore, the equation comes out to be y equals to x square plus 3x plus 1. So that is how we use integration and we find the equation of a curve based upon the gradient function. Now let's scroll up and look at the equation for a second. In this particular integration technique, we integrated term by term. The question is, can we integrate it as a bracket with a power of 1 and get the same result? Let's find it out. So we have dy by dx equals to 2x plus 3. Y is equals to integral of 2x plus 3 dx. Let's put a power of 1 on top of the bracket. Yes, it's a linear function. And the second thing is the power is anything but not equal to -1. That means chain rule is applicable. So let's start with the chain rule. The bracket remains as it is. Power increases by 1. Divide by the new power. Don't forget to divide by coefficient of x or derivative of bracket. That is the same thing when we are dealing with a linear expression plus a constant of integration c. 1 plus 1 is 2. 2 into 2 is 4. So this is 1/4 2x plus 3 whole square plus c. Now let's use the point on the curve 1, 5 to evaluate c. So let's plug in 5 in place of y and 1 in place of x. 5 is equals to 1/4 2 into 1 plus 3 the whole thing square plus c. That is 1/4 2 plus 3 is 5. 5 square is 25 plus c. That is 25 over 4 plus c. That is equals to 5. 5 minus 25 over 4 is equals to c. Therefore, c comes out to be -5 over 4. Therefore, the equation of a curve is y is equals to 1/4 2x plus 3 whole square minus 5 over 4. Now, this equation definitely looks different from the equation of a curve which you see over here. Or are they really different? Let's do one thing. Let's simplify this equation further. So this is 1/4. And this is 2x plus 3 whole square. That is 4x square plus 6x plus 6x plus 9. And this is minus 5 over 4. Let's take this 4 common out. So we have 1/4 and 4x square plus 12x plus 9 minus 5. That is plus 4. And let's simplify it by dividing each term by 4. So what do we get? 4 over 4 is x square. 12 over 4 is 3x. 4 over 4 is 1. And now we have the same equation of the curve as before. So it does not make a difference whether you do the integration by integrating individual terms or by using chain rule. But of course, the condition for chain rule has to be met. It should be a linear expression, and the rule for power is the same for before. The power could be anything, but the power should not equal to -1. So what have we learned in this video? Dy by dx, the gradient function can be integrated to obtain the equation of the curve. And what else have we learned? We have learned that how do we evaluate the constant of integration, which we usually denote by the symbol c. What we do is that we plug in the value of x and y in equation of curve, and that is how we evaluate the constant of integration c.